So today we are going to talk about STM32 Nucleo Generate Modulation with timers using STM32 Cube ID. So in this session I will take you through the basic of PWM, which is pulse modulation, and how to create STM32 project for generating pulse modulation signals using timer peripheral. So we will also create an LED dimming project using this technique. So PWM is a widely used technique in embedded systems to control the power delivered to electronic components such as motors, LEDs and servos. It is a method of producing analog like signals from digital microcontroller, right? So first let's talk about what is PWM. At its core, pulse modulation involves rapidly toggling a digital signal between high and low levels with varying in duty cycle. Okay, so the duty cycle represents the portion of time the signal spends in the high state within a given period. So by adjusting the duty cycle, you can effectively control the average voltage or current applied to a load, allowing you to control its behavior. So for example, if you want to generate a 2.5 volt signal from a digital source like a microcontroller, which provides either high or low signal only. So we can generate a duty cycle of 50% by the help of pulse modulation. This 50% duty cycle will produce an average voltage like 5 into 0.5, which is equal to 2.5 volt, right? Okay. So here we will create a LED dimming project in STM32 Cube IDE by using STM32 Hall API, which is nothing but hardware abstraction layer. We will control the brightness of the LED by generating PWM signal using the timer 2 peripheral of this particular STM32F446RE microcontroller. Actually the hardware part is very easy. We just need to connect LED, ground and some pin. Here I am going to take A0 pin, which is from analog, right? Okay, so before getting into the project setup, let us talk about this important thing, which is you can convert this masterclass into 1 month internship on STM32. So the actual amount of this internship is for 1,999, but there is a discount amount which is available for you, which is only for 799. So use this registration link to register for 1 month internship. So what you will get in this 1 month internship: 30 days of live session plus 30 days of recorded session, 30 days of presentations for download, 5 project source code for download, 1 month internship certificate, participation certificate, 90 days of access to the courses, 4 hackathon live sessions, and you can join to the community group. And also there is a 3-in-1 bundle courses available for you. In this, STM32 is the default course, you can't change that. Among these 4 courses, you can choose any 2 by your own. And the actual amount of this bundle course is for 3,000 rupees, but there is a discount amount which is available for you, which is only for 1199. So use this registration link to register for 3-in-1 bundle course. And in this 3-in-1 bundle course, you will get 90 days of live session plus 90 days of recorded session, 90 days of presentations for download, 10 project source code for download, 3 internship certificate, 1 year validity to the courses, hackathon live session, and you can join to the community group and you will get assignments and mock test. And while making your payment, don't forget to add the courses that you want in the domain tab. Okay, so now let's go for IDE. Let me go for a new STM32 project. Okay, so now go to system core, enable this RCC and go to clock configuration, HSE PLL clock. Let me change this to 8 and here I am going to go for 80 megahertz. I am going to hit enter. Okay, so now get back to the pinout and configuration, go for timer 2 and go for clock source, turn this internal clock, and in channel 1 turn pulse modulation generation channel 1 and go for parameter settings, and over here you have to change the prescaler value to 80 to 1. Okay, and also there is a thing called counter period value. You have to change this also. Hit enter and go for connectivity. Use R to enable this and save this, generate your code. Okay, and over here you just scroll down, and after this I'm going to add all library, timer, pulses modulation, start. Okay, so H timer 2, timer channel 1, and inside while loop I'm going to give a for condition, for loop. So integer type I am going to initialize this with 0, and then I which is lesser than or equal to 100, and then I'm going to increment it. Okay, so now timer 2, here I'm going to use CCR1 register. I'm going to initialize this with I, and then I'm going to give a delay of just 5 millisecond. Okay, and then another for loop, integer I am going to initialize this with 0, and then I which is greater than or equal to 0, and then I'm going to use decrement, and here timer 2 I'm going to use CCR1 register, right? Initialize this with I and delay of 15. Okay, so this is our program. Let me save this and let me build this. Let me check, do we have any error or not. Okay, so now this has to be connected with the ground, and this is supposed to be connected with A0 pin, analog pin, right? Okay, so now I'm going to upload this program. I think this jumper wire is loose connection, that's why it doesn't give output properly. Let me show you. I have already recorded the output video. You can see this. This is how the output will be. The LED will be bright and then it will dim the LED itself.